Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video is a few days late in coming, but better late than never. And this is the 2021 Advent of Code. This is day 24. The problem is called Arithmetic Logic Unit. And basically, it comes down to, there's a lot going on in this problem. Here we go. And it kind of comes back to, since it's using arithmetic logic unit, it comes back to assembly language class, or just understanding how to make the computer do what it needs to do, opcodes and all sorts of crazy stuff. This kind of reminds me when I started Advent of Code in 2019, and when I did that, then there were I think it was 6 or 7 problems that kind of built off one another over the days. And you basically built a mini computer, and this problem kind of reminds me of that whole series. And for this one, kind of tricky here, because also there's I don't remember the name of the algorithm, but there is a way to determine if a credit card number, a 16-digit number, is valid or not. And it's a pretty simple algorithm. You just do this, you do that, and it gives you a yes or a no. And in this case, it does the same kind of thing. Give me a 14-digit number, and I'll tell you if it's a model number or not. But there's so many more calculations to make this thing work, to give you the true or the false. And especially if the question here for part 1 is, what is the largest 14-digit number that doesn't have zeros in it that is a model number? I was kind of looking into this. It could take you years to find that solution, especially when you know what digit that number starts with. You could be spending a huge amount of time deducing and figuring out that the number isn't anywhere close to as big of a number as you think it is. But anyway, so here's a computer. Is this basically you're basically emulating the arithmetic logic unit with these 6 different operations. So add. So this is exactly like what you would see in x86 assembly language. Add a comma b, where you just a plus equals b, and mul is a times equals b. In x86 it gets a little more complicated since you're using the EAX and EDX registers to do multiplication. Same with division. You'd be using idiv and imul for those kind of things. So div, just a divide equals b. Mod is the same thing. Modulus is just division, where you keep the remainder instead of keeping the quotient. So just a mod equals b. And then this is just a little bit different. The equals, kind of in a way, you're testing one value against another, and you're gonna store a 1 or a 0 into the a, depending on whether that's true or false. And then this is where the complexity comes a little bit when it comes to input a. This is basically quote unquote ask the user for some input. But the reality is, no, you're not going to be asking the user for input. You're going to be generating a 14-digit number and then parsing that thing down and inputting a digit for digit inside of there. And the code has 14 separate digits for input. So that's basically what I give you. Basically, they give us a program, we run through, and we just basically give it a 14-digit number, and it goes yes or no. This thing is a valid model number. And at the end of the day, the goal is to find the largest 14-digit number that works. And again, huge amount of computing power if you brute force this. I don't know how long. I really do not know how long it would take, but it would take quite a long time to make it work. So they gave you some examples of making this thing work and so forth. So the first part of the problem, before you even think about doing stuff here, is where's blah 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 blah. I've given you the whole find the valid, what is the largest model number, except I don't want to give you the number just yet. But you can see this program. The first thing would be, well, how would I even convert that code in this language, this whatever assembly language, if you want to think about it, whatever assembly language, into something that I can use on my end, since there is no, since I'm emulating whatever CPU this thing is, or the ALU. So the first step there is, here is my input. Here is my 200 and whatever lines of code in assembly language, and I need to convert that into something I can use. So I start with Python, and of course this is nowhere near maybe the best way to do things, but I just wanted to have a little fun with it. So I took Python, and this is just my Python code here, and what it does is it takes this code here and it converts it into C++. Not a full program. You'll see why, because I don't need to write a full program for that just yet. But you can see basically I just read everything in and I read it into a list of lists basically here where or not, yep, it is a list of lists, right? Let me see what happens if I run this, make sure. It has been a while since I looked at my code here. And so, yep, there we go. It's a list of lists. And so basically every token is stored. And essentially it just goes through and says, hey, for every operation I have inside of there, just check to see what the opcode is, if it's input, equal, add, mul, mod, or div. And then just do what I need to do to convert that into its appropriate C++ stylings. And when you do something like that and you run this thing through, you end up with code like this. This is just, again, because the input it's not just cut and dry. We're going to be actually, for these W values, we're going to be trying values 1 through 9 in all these cases. But you can see that, this is essentially my CPP file. And this is all of the code that, basically x multiply equals 0 is the same as mul x 0. Because it says x because this is supposed to be x times equals 0. Or x plus equals z. X plus equals z. And you can see everything works, everything is there. Everybody's happy. And so here this is my C++ code, or it doesn't even have to be C++, it could be a lot of different languages now that I think about it, right? C# and Java and you name it, because it's simple enough. Maybe not these kind of things would probably break down just because C++ allows that explicit typing from bool into int without having to add anything to it, but other languages do not have that. Excuse me. So anyway, so there is my C++ code, and that's kind of where the Python ends on this side. And so because I wanted something that runs a lot faster to get this thing going. So there is that. And what do I do with that thing now? I work over here on this end, and I took all that code and I broke it up into 14 different parts. And again, I was just having some fun with this. And so I did basically for every part there until I saw, let me see if I can pull it back up here. Basically, I stole all the codes. I stole all the code up until like you see another input, and I put that into it. So this would be code part 1, and then this here would be code part 2 and 3 and 4. And there's 14 parts. And it might look a little different here than what you're expecting, only because even when it says input W, I don't have to do anything with W. I don't like it. Well, let me find it. Let me bring it back here one more time. So like this, it says input W after this Z plus equals Y, but I don't do anything with it until I get down to here. So you'll see there's going to be there's 5 lines of code that I basically kind of shift up. And I don't know if it speeds up the program at all by doing that, but I just figured even though it says input the W, there's no reason why this has to be line 37. It could be all the way down here, right in here in line 40, 42 or 43, whatever, when everything gets shifted around. Probably 42. 1, 2, 3, 4, 5. Yep, it'll be 42. But again, there's 14 parts, and I've broken this up into 2 separate files, and I can drag this over now. That very, very small here, but again, it's just all of that code dragged in. Okay, so now I've got my 14 code parts. So now the way to make this so I don't brute force this is to basically keep track of a set of all the registers on a fictitious CPU, ALU, whatever you want to call it. Maybe I'm calling it the wrong. No, these are the registers. This would be the CPU, and so there's 4, there's W, there's X, there's Y, there's Z, and I maintain the model number as I go along. And I'm keeping these all as long longs because I want to make sure I keep these as 64-bit quantities. because this model number especially becomes a 14-digit number, and you need long to be able to work with a 14-digit number. And the same with this. We don't know what these values are going to become. I know what W will be, but I can't speak for X, Y, or Z. Okay, so once I have this kind of setup, I also have to maintain, I also have to worry about how do I sort this thing, because again, I'm going to create a set of CPUs, and the reason I'm creating a set of them is so that if I find duplicates along the way, that I don't have to, I don't want to calculate 9 to the 13th power different computations. So if I get to a specific spot where I do a code part here, one of these code parts, and I figure out that the X, the Y, and the Z registers are all the same as something I've already done before, then there's no reason to maintain that twice. Because the W doesn't necessarily matter, because that's just holding our inputs, but the X, Y, and Z, if those are all the same, then we know that we've basically done the calculation before, and we can kind of merge the two together and just work from then on in. The only difference being, since I'm trying to find the largest model number, then I just maintain the larger of the two model numbers when I find a conflict, when basically if I try to add something to a set and it's already in there, whatever the larger model number wins out, because eventually, again, like I'm saying, the largest model is supposed to win out overall, over all the computations. So then by sorting, because this is going to be a set, I sort by X value first, then Y value, and then Z. And then, so, basically just making sure if this is less than, that's true, but if this is greater, then this is false, then this has to be equal, and so forth and so on. So this works my way through, so I get a consistent sorting algorithm. And again, since I did this myself, again, W and model does not matter. They matter for the calculations, then this matters for the end result, but for the sorting, I only care about X, Y, and Z. And to be honest, I probably should have done Z first, just because then you could see the thing either first or last if you're printing this thing out. Anyway, so that is all I need for the CPU class. This has to be a specific operator here where it's the dual operand here. I can't just create a member function for that operator. And so that's all I need there. And so here are the externs for this, so I can access this code in another file, just like I can extern and use my quote unquote CPU here. The W, the X, and the Y, and Z are here, and these code parts are there, so they kind of work back and forth. And I only did this so that the code itself is kind of hidden from this, is kind of hidden away, abstracted from the code that it's that is working off of. Okay, and so when I start this thing off, I have a set of CPUs, and it's basically just the starter, which is 0 for W, 0 for X, 0 for Y, 0 for Z, and so forth and so on. And again, these are the registers, so that's what it says to start from. The whole program starts from 0, 0, 0, 0 with model number 0. And so this is a tricky part here if you've never, especially in C++, if you've never worked with function pointers. This was just a way so I wouldn't have to duplicate my code 14 times over. So this is just, and so I'm doing this 14 times, where I'm going to do all the code for part 1, and then for all of my CPUs, and I'm going to do all the code for part 2, all my CPUs, and so forth and so on, and I'm going to do all 14 parts. And so when I start, again, I have one CPU, and this says for each CPU, I'm sorry, for code part 1 here, the next generation, start with the CPU I have, and then go ahead and try all 9 values of W's. So W is equal, the W gets set by this. The X and the Y and the Z are already set forth in the CPU that was generated, which is just 0 values. And then figure out what the new model number is by adding the new digit to it. So, it'll start as a 1-digit number, then it'll make it a 2 and a 3 and a 4 and a 5 and a 6 and a 14-digit number. And then this is the tricky part with the function pointers. Look at that code has just got awful, right? Look at that bunch of symbols there. But this just means that I can set up an array of function pointers that will call these functions rather than, again, having to rewrite up the code all over and over again. So then this code will go in here, and it will affect all the, X, Y, W, X, Y, and Z are modified as need be. And then I generate a CPU object from that, and I then try to see if I can put it into the set of the next generation. Again, I do not want to mix up the set that is the current generation from the one that is the next generation until after all the computations are complete. And so when I do that, and I say, okay, can I find this, whatever this is, can I find it in the next generation? And if I can't, then I throw it in. But if I can, that's what this, if I fall through here, I can find it inside of there. And then I just check to see if if the new model number is larger than the old model number, then go ahead, and I just had trouble. Maybe I can go ahead and do this so I don't have to erase and insert. But I say erase the old one and insert the new one. The x, remember, because of this, the way this is equality here, defined, the x, the y, and the z values are going to be identical. I don't care about the w, and it's only the model numbers that need to be, that are going to be modified and maintained. So I just do that. So one CPU becomes 9, 9 becomes 81, and it gets larger and larger, of course, but not as large as you might expect, because over time, as I was saying, and you'll see here, well, let me just run it. Run, build, bug without debugging. You'll see that the first couple generations are really quick, of course, already by there we go. And so as I'm going and going and going, you think 9, 81, 729, well, 810. So there are a lot of duplicates, because this should be 729 times 9, 6,400, whatever it is, 6,400. But you can see things going. And again, a 5.9 million element set, accessing every element in there and then doing more calculations and so forth and so on can be a little daunting. So this will take a little longer than you might expect. It takes a minute or so. But again, at the end of the day, by doing all of this work, and then when I'm done with all of this, just basically saying, let's reset the thing and saying, okay, the current generation is now whatever the next generation was, and start again and start again and start again. And after 14 passes, whatever comes out, if the CPU Z value is a 0, then that's our solution. And it just turns out that there is only one that comes out, because of the way that everything just kind of worked out. That doesn't mean there's only one value. It just gives me the largest one. And I was expecting part 2 to ask how many there were, but part 2 basically asks a different question, and I'll get to that in a minute or so. But as I'm going through, so that's it. That's the whole program. I know that's it, right? Going from Python into C, and then writing C code to go through a set as fast as possible. Yeah, that's all there is to it, right? But I guarantee you in a minute or so here or whatever, you will have the correct answer. And let me just predict this right now. I'll just say the correct answer will be this number, 51983 999999999494799. And so there we have it. And come on, guys, come on, let's work this out a little faster. There we go. We're getting closer. And then this part here, maybe I think this part goes a little faster because maybe there's a lot of the same values. But again, at the end of the day here, I'm not delaying just for for viewership or anything like that. I should have started this a little bit sooner. And I am running this in release mode and all that whatever stuff, so this runs a lot faster. I forgot all about that, because originally when I ran this, I started this, then I knew it was going to take some time because I was in debug mode, and I ran it, and I went to the zoo with my family, and I came back and the answer was right there staring right at me, and I was so happy to see it. And ironically, the first couple times I tried this, I got the wrong answer. There it is. See, there's my right answer. The first couple times I did this, I got the wrong answer, but it turns out that I actually got the answer to part 2 accidentally. And so, but this is the end of part 1. There's my part 1 solution. And so now part 2 is the same thing. Like, what is the smallest number? And there it is. I can give it right. That came up immediately the first time I ran this accidentally. And of course, it's not going to give me the right answer. But when it was part 2, it was like ironic. If I had just tried that instead of running the program again, I would have gotten this correct. So what is the difference? How do I change my code so that this thing works? Oops, not that one. I want this guy. All I have to do on this end to make this thing work is to take this one little symbol right there, which is a greater than, turn it into a less than, and that will do it. Because I'm looking for the smallest number, not the largest one. And so I will let this run after I'm done saying my goodbyes here, and I will stop this program when it gives me the correct answer. So thanks for sticking it out with me as always. If you have any questions, or if I misspoke, because I know even for a 20-minute video, I know I speak fast when I'm excited about the things I'm talking about, and who knows who's listening, if anybody at this point anyway. And so thanks for sticking it out. Part 24 is done. I only have a couple more of these problems I even want to try. Some of them are like, I don't even fully understand what the problem is even asking, let alone anything else. But this, I know we can do better than this. I just don't know how. I'm not a mathematician by trade, and so forth and so on. And so, Happy New Year for everybody if you're watching this in the day or so after I make this. And if not, Happy New Year. Happy whatever year you're in, whatever month you're in. Hope you have a fine 2022 or 2023 or beyond. And so I'll see you guys in future videos. And again, this thing will be done in a second. I guess I'll just wait. Oh, there it is. And there is the answer that I was telling you guys there. So take care, everybody. Have a great day. See you.